Hello, good day seniors. This video lesson will answer some selected problems regarding our topic, the factor and the remainder theorems. Let's solve this problem. Suppose that p of x is a polynomial with integer coefficients. The remainder when p of x is divided by x minus 1 is 1. From there, according to the remainder theorem, that means p of 1 is equal to 1. Next is the remainder when p of x divided by x minus 4 is 10. So from there you can get that p of 4 is 10. If r of x is the remainder when p of x is divided by x minus 1 times x minus 4, find r of 2015. So if you will divide p of x by these two, the product of x minus 1 and x minus 4, that means you will have a quotient, a certain quotient corresponding with it, and then multiplied to the divisors x minus 1 and x minus 4. So notice that your divisor is second degree. When you multiply this two, you'll have a second degree. Therefore, you will get a remainder which is of the first degree of the form ax plus b. So this is your r of x. So now we will use these two hints in the problem for this and look for the values of a and b for our r of x. Let's start with p of 1 equals 1. So p of 1 is equal to, notice that when you substitute 1 to this factor 1 minus 1, it will become 0. So this whole thing will just become 0. And then 1 times a plus b. So this is a plus b. And it's equal to 1 according to this condition. So you have this equation. Now if you use p of 4 is 10, that means you substitute 4 to the right side. So when you substitute 4 here, it will become 0. So the whole thing will be 0. And this will be left with 4a plus b. And it's equal to, according to the given, 10. So you'll be dealing with these two equations and solving it by simple system of equations. 4a minus a, 3a, b minus b will cancel out. 10 minus 1 is 9, therefore a is equal to 3. So if a is 3 here, 3 plus b is 1, obviously b is what? 3 plus b is 1, so b is negative 2. Therefore your r of x, here, let's put it here, r of x, ax plus b, ax plus b. Now you have your a and b simply 3x minus 2. So this is your r of x. And if you're asked this one, in particular r of 2015, so r of 2015, it is simply 3 times 2015 minus 2. And 3 times 2015, that will give you 6045 minus 2. So that's 6043 for this problem. Let's go to the next. When the polynomial function f of x is divided by x plus 1 times x plus 2, remainder of negative 5x minus 2 results. Let's write it first before we proceed in finishing the problem. F of x, when you divide it by these two, x plus 1 and x plus 2, you will have a certain quotient corresponding with it, and then multiply it to x plus 1, then x plus 2, and a remainder. So this part is the remainder, which is already given, negative 5x minus 2. So I wrote it this way, so plus the remainder. So when this function is divided by this one, in this case x plus 2, x plus 3, this remainder will result. So again, just write it. F of x is equal to a certain quotient function corresponding to these divisors, x plus 2 and x plus 3. Okay, and then the remainder, which is plus negative dx plus 2. Now let's make things clear that this q of x here and q of x in the second are different functions because the divisors are different. So anyway, let's continue. What will be the remainder of the function if this is divided by x plus 1 times x plus 2 times x plus 3. Now, we will be working with these two first so that we know what the values of f of negative 1, f of negative 2, and f of negative 3 in the problem. So that in the actual problem, you'll be asked what is the remainder when our function is divided by the product of this time these three factors. So it's another quotient multiplied to these three divisors, and then x plus 3, and then the remainder when you divide the polynomial to these three. So notice that this 3, when you multiply this, a third degree polynomial, so your remainder must be a second degree polynomial of the form ax squared plus bx plus c. Remember, your remainder is always 1 degree lower than the degree of your divisor. So notice that here in the problem, we need the values of f of negative 1, f of negative 2, and f of negative 3. That's what we will be getting from these two. So let's start here. So if I use x is equal to negative 1, if x is negative 1, obviously the left side is f of negative 1, and it's equal to, this will become 0, so the whole thing is 0. Negative of negative 1 is 5 minus 2, that means f of negative 1 is 3. So if x is equal to negative 2 for this part, again, the left side will be f of negative 2 since you're substituting negative 2 to x, and then the whole thing will be 0 because this factor will be 0, and then you will be left with this negative 5 times negative 2, that's 10 minus 2, so it means your f of negative 2 is 8. And then you notice that we still need to get this one, x plus 3, so we'll be using the second for that. If x is equal to negative 3, that means f of negative 3 in the left side, again you substitute negative 3 to that, this thing will become 0, this will become 0, and then negative 3 times negative is 9 plus 2, get 11. So these are the clues that we need so we can answer the real problem here. Okay, so I'll just erase this one, we're done with this part. Okay, so now we have what we need. We have f negative 1, which is 3. So using this first, so we have 3, because if we substitute negative 1 here, get 3 is equal to, this will be 0 because negative 1 plus 1 is 0. This would be negative 1 squared a, negative 1 times b is minus b plus c. So that's what we got from this clue in the problem. Now let's have this. If f of negative 2 is 8, so if you substitute negative 2 in all x here, we get 8 as our function, the value of the function. So you have here 8 is equal to negative 2 plus 2 will become 0, so this will be 0. Then negative 2 squared, that's 4a, negative 2 times b is minus 2b plus c. So we're done with this. Now the last one, if x is negative 3, that means f of negative 3 is 11, so that means 11 is equal to negative 3 plus this. Now again, this thing will become 0 regardless of the value of this quotient because it will be multiplied to 0 anyway. So we have negative 3 squared, that's 9a, and then negative 3 times b is minus 3b, and then negative plus c. So what we have here are 3 equations with 3 unknowns. So simple system of equations will do the trick, then solve for the values of a, b, and c. So again, just subtracting these 2 equations to eliminate c. 8 minus 3, get here 5. 4a minus a, that will be 3a. Negative 2b minus negative b, that will be negative b. And obviously c minus c will cancel out. Now I will subtract these 2. 11 minus 8, that will be 3. 9a minus 4a is 5a. Negative 3b minus negative 2b, that will give you negative b. And of course c minus c will cancel out. Now these 2, again, this time I will subtract 5 minus 3, you have 2. 3a minus 5a, that will give you negative 2a. And then negative b minus negative b will cancel out. Thus you will have a value of a equal to negative 1. So you have your A. Now to get B, just use this, any of the two. So anyway, you have negative 1 as your A, and 3 times negative 1, that's negative 3. So 5 equals negative 3 minus B. That means 8 is negative B, or B equals what? 8 is negative B, or B is negative 8. Let's check that. 3, negative 3 plus minus negative 8, that'll give you 5. So this is correct. B is negative 8. So to get C, use any of these 3. So I'll be using this one. I have A already. That's negative 1. Minus, I have my B already. So negative 1 minus negative 8. That will give you negative 1 plus 8, or 7. So 3 equals 7 plus C. And that will give you C. 3 equals 7 plus C. Therefore C is negative 4. So therefore this one, your remainder, that's your remainder, ax squared plus bx plus c, is actually a is negative x squared, b is negative 8x, and then c is minus 4. So this is the remainder when you divide the polynomial by these 3. You notice how the factor and the remainder theorems are used here. When the problem says, when you divide, you give your remainder, that means f of that number equals the remainder. When in the problem says it's a factor, that means f of that number will be 0, because if it's a factor, it will have no remainder. Remainder is 0. Now, I wish we have more time, because I want to answer the third question, but we only have 3 minutes left, so let's leave that to the next video lesson. So anyway, the first two problems are very similar to this when you apply the same approach and technique. So let's go to my very favorite part, the best way to learn, to do it yourself. Now, we will be posting your problem set 1.3 later this weekend, probably Sunday. So I hope you answer it, do it yourself, because the best way to learn is to do your problem set without just copying from your sources. Good day, seniors. Peace out.